All right, our lesson for today is 5-9, and our objective would be the student will be able to perform operations with complex numbers. And our vocab that's new today is the complex plane. So we've worked with complex numbers. Remember, it has a real part, the A, and the imaginary part, which is the BI, is our general case. Well, the complex plane is simply that we can take a complex number and we can now graph it like the coordinate graphing system. The x-axis is the real part of the graph, and the y-axis is the imaginary part. Okay? So, as an example, if we have the number 3 plus 7i, then we would just go to our plane and we would go, the real number is 3, and so we go 3 to the right and up 7, and so this point would be right there. If I had negative 2 minus 5i, now I would go 2 to the left and down 5, and so this point would be 2 left and down 5, and so it would be right there. And if I did, let's say, negative 5 plus 2i, then I would go 5 to the left and up 2, and so that point would be right there. So it's pretty easy to do. You just have to remember that the x-axis is your real number part and your y is the imaginary part. This is going to lead into absolute value. So if you remember absolute value from the first unit, absolute value, remember, is the distance from 0. And so what we're going to do is, it says a plus bi is the distance from the origin to AB in the complex plane, and it's denoted by the absolute value of a plus bi. And to find that, you simply take the absolute value of a plus bi is equal to the square root of a squared plus b squared. So if we go back to this, if I ask you to find the absolute value of 3 plus 7i, you simply take the square root of a squared, so 3 squared, plus b squared. Now b, remember, is just the unit we have here, which is 7. And so we would have 9 plus 49, so we'd have the square root of 58. Now, if you can simplify that, you should, but there's no perfect squares that go into 58, so we would leave it that way. Let's take the second one. Whoops. The second one. Let's take the absolute value of negative 2 minus 5i. So now we're going to take the square root of a, which is negative 2, plus the absolute of negative 5 squared. So this is going to give us negative 2 squared. Remember, when you square a negative number, it will always be positive if it's written this way, plus negative 5 squared, which would be 25. And so this would give us the square root of 29. So again, we don't have any perfect squares in 29, so we would be finished at that point. You can see what's going to happen with the next one. It's just going to be the square root of negative 5 squared plus the square root of 2. So negative 5 squared plus 2 squared. So again, we get 25 plus 4, and we get the square root of 29 again. So the negative signs really don't affect it, because when you square it, that's going to be a positive number anyway. So the example that I'd like you to try now is the absolute value of 5 minus 7i. So go ahead and try that. I'll go ahead, we can pause it here, but I'll show you how it's done if you don't get it. So this would just become the square root of 5 squared plus a negative 7 squared. And so we get 25 plus 49 equals the square root of 74. Again, no perfect squares, so we would be finished at that point. So part of the assignment, you're going to be doing the absolute value of a complex number, square the A term, square the B term, and then take the square root of that. The next thing is we're going to be able to add and subtract complex numbers. Remember, you just add or subtract the real parts, those are the like terms, and the imaginary parts. And you do it just like you were adding and subtracting like terms. So if you go back to, let's say 3x minus 4y plus 5y minus, let's go 7x. Remember, you can only add and subtract like terms. So that would be, we have 3x minus 7x would be a negative 4x. And negative 4y plus 5y would be a plus y, and we would be finished. So nothing really changes when you do imaginary numbers. The common mistake is, because a lot of times the book will write it like this, is that people will see the parentheses and they'll do the distributive property on this. I know a lot of people in my class, when they had the one on the example, the preview, the pretest, they distributed this and did it like multiplication because they're used to the parentheses. But you have to check the sign between. So this is a plus sign. So we add the like parts. So we have 3 plus 2 is 5. And then we have negative 4i plus a negative 7i would be a negative 11i. And we're finished. The I you treat just like a variable. You just add and subtract the numbers in front. And we're finished with that one. Let's do a subtraction problem, because a lot of people make mistakes. Let's do the same problem. 3 minus 4i minus 2 minus 7i. Now my recommendation is, don't work with subtraction problems when you have parentheses. Just change it to addition. Because remember, subtraction is the same as adding the opposite. And so we take the opposite of this, and so we change the sign of both terms. And now we do an addition problem. So we have 3 plus a negative 2, which would be 1. And we have minus 4i plus 7i, which would be a plus 3i. So again, the common mistake is people will multiply this. So, example number 2 I'd like you to try now. 3 minus 4i minus 5 minus 7i. So try that on your own. When you finish that, this is how it should have looked. Again, I would take and change the subtraction to addition. Change the signs. And so we get 3 plus a negative 5 is a negative 2. And we have negative 4i plus 7i is a plus 3i. So, fairly easy. Remember, just treat the I just like if it was an X. Make sure that if it's got addition, subtraction between it, that you don't use the distributive property. So that would be addition and subtraction. Next, you're going to be asked to do multiplication and division of complex numbers. So again, you do it just like you would do with variables. So if we have 3 minus 4i times 2 plus 7i. Now we do distribute this. So again, you take 3 times both, whether you use the FOIL method, the claw, smiley face, whatever method you use to do these. And then you have to take 4i times both. And so if I do this, we get 3 times 2 would be 6. 3 times 7i would be 21i. Negative 4i times 2 would be a negative 8i. And then negative 4i times 7i, so negative 4 times 7 would be a negative 28. And then I times I would be I squared. This is the most common mistake, is people don't put I squared. So make sure that you do that. And then we have to go back to what you learned when we first talked about imaginary numbers. Remember, I squared is equal to negative 1. So now I need to simplify this further. Well, if I squared is negative 1, this negative 28 times the negative 1 becomes plus 28. And so now if I add the like terms, I've got 6 plus 28 is 34. And then a minus 21, or plus 21i minus 8i would be a positive 13i. And you're finished. So the common mistakes on this is people forget that this I squared is a negative 1. Well, two common mistakes. They'll go I times I and they'll put negative 28i and not put I squared. And then others forget that I squared is a negative 1. You should end up with that I squared, and then the constants can be added together. So let's try another one. Let's take 7 minus 3i times 2 minus 5i. So we get 7 times 2, 7 times negative 5i, negative 3i times 2, and negative 3i times negative 5i. So 7 times 2 is 14. Then we get 7 times the negative 5i would be negative 35i. Then negative 3i times 2 is a negative 6i. And then negative 3i times the negative 5i is a positive 15i squared. Because I squared equals negative 1, this becomes a negative 15. And so we get 14 minus 15 would be a negative 1. And negative 35 minus 6 would be a negative 41i. So you have to be careful with that I squared. So let's try as example number 3. 3i minus 4i and 5 minus 7 times 5 minus 7i. So go ahead and try that. And after you've done that, we'll come back and show you how to do it. So to do this, again, you should have taken 3 times 5 and 3 times negative 7i, negative 4i times 5, and negative 4i times 7i. So 3 times 5 is 15. 3 times negative 7i is a negative 21i. Negative 4i times 5 is a negative 20i. And negative 4i times the negative 7i is a positive 28i squared. Again, this is going to become I squared is negative 1, so negative 28. So if we combine like terms, we have 15 minus 28 is a negative 13. And negative 21i minus 20i is a negative 41i. Remember, when you add and subtract, it's just I, because you're doing the numbers, you're just doing the negative 21 minus 20. It stays I, it does not become I squared. That's another common mistake. Now I said we were going to multiply and divide. So the division is a little bit tricky. So we're going to simplify fractions with complex denominators. So that's going to be where we have something like this. 3 minus 4 minus 2i. And we have to take 3 and divide it by 4 minus 2i. This we have to be really careful on. If you remember back when we talked about simplifying radicals, let's say I had 5 over square root of 2. Remember, we can't leave the square root of 2 in the denominator. So if I was to get rid of that, remember we multiplied by square root of 2 over square root of 2, because that's equal to 1. And we get 5 square root of 2 over 2. Well, remember, I is really the square root of negative 1. And so it's a radical, so we can't leave that down here. But the problem is the same that I would have if I had a problem like this. 5 over 3 plus square root of 2. Because if I multiply this by the square root of 2 to get rid of this square root of 2, well, on top I'm okay. I get 5 square root of 2. But on bottom, what happens is I have to take this and distribute it. And so I would get 3 square root of 2 plus square root of 2 times square root of 2 would become 2. And even though I got rid of this one, I added one. And so we have to have a way to get rid of this I in the bottom, or in this case, if you wanted to get rid of the square root, you've got to have another way to do it. And that's going back to the complex conjugates. So if you remember, the complex conjugate of 4 minus 2i, you take the opposite of the imaginary part. So that would become 4 plus 2i. And you multiply both the numerator and the denominator by this. So in this case, we would distribute and we would get 3 times 4 is 12, and 3 times 2i is 6i. And here's what happens on the bottom. Again, we're having to distribute this, so you're taking 4 times both and negative 2i times both. But this is what's special about when you multiply conjugates together. 4 times 4 gives me 16, and 4 times 2i gives me 8i. And negative 2i times 4 gives me negative 8i. And negative 2i times 2i, which gives me a negative 4i squared. Okay? So the 4 times 4 is the 16. A positive 8i, a negative 8i, and then again, negative 2 times 2 is negative 4, and I times I is I squared. Well, what always happens is, when you multiply conjugates together, those middle terms are always opposite, and so they cancel out. The I squared we already know is negative 1, and so this becomes 16, and that negative 1 times negative 4 will be positive 4, and so we get 20 in the denominator. Now we don't have an I in the denominator, so we're okay. The last thing you should always do, though, again, is check to see if you can reduce. And in this case, 2 goes into all of these numbers, so I can reduce this to 6 plus 3i over 10. And that would be my answer. So it's a little bit tricky, so let's go through another one, make sure we're okay on this. Let's take a little more complicated. Let's put 2 minus 3i on top and 4 plus 2i on the bottom. Again, the numerator doesn't make much difference. All we're worried about is this denominator. We can't have that I there. So again, our conjugate is the opposite of this, so 4 minus 2i. And so now we distribute. Now I put a binomial on top and bottom, so again we have to double distribute that. So we get 2 times 4 is 8. 2 times negative 2i is negative 4i. Negative 3i times 4 is a negative 12i. And negative 3i times 2i is a positive 6i squared. So if I just simplify the top, we have, remember this I squared becomes a negative 1, so we get a negative 6. So 8 minus 6 would be 2. So that's in the numerator. And then we have minus 4i minus 12i, which would be a minus 16i. So that would be my numerator. Now, when we do the denominator, again, you can go through this process of multiplying this, but remember your outer and inner terms will always cancel. We'll get that 4 times 4 is 16, and 4 times negative 2i is negative 8i, and 2i times 4 is a positive 8i, and 2i times a negative 2i is a negative 4i squared. I don't really need to multiply those outer and inner terms together because I know they are always going to be opposites and cancel. So you can take a shortcut on this and just multiply the first numbers together and get 4 times 4 is 16, and then just multiply the last terms together and we get 2i times negative 2i, which is a negative 4i squared. Again, we can do that because the outer and inner terms will always cancel. Well, I squared is negative 1, and negative 1 times 4 is 4 times negative 4 is positive 4 plus 16, so it becomes 16 plus 4, which is 20. And then again, 2 goes into everything, so I get 1 minus 8i all over 10, and I finish that. So, I'd like you to try this one. So do this. It's example number 4 for those in my class. Again, we have the half sheet. You might have to do it on the back, but example number 4, I'd like you to try this. A fairly complicated one, so go ahead on that. Now that you've finished it, again, we can just multiply by the complex conjugate, so that would be 4 plus 5i. So again, distribute. 7 times 4 is 28. 7 times 5i, 35i. 4i times 4, 16i. And 4i times 5i would be 20i squared. That's my numerator. Remember, this now is going to become negative 20 because I squared is negative 1. So 28 minus 20 is 8. And 35 plus 16 would be 51i. Our denominator, we're going to multiply this together. So again, we're going to skip this 20 and negative 20i because they're going to cancel out and just go 4 times 4 is 16. And negative 5i times 5i is a negative 25i squared. So we get I squared is negative 1, so this becomes 16 plus 25, which is 41. And there's nothing that goes into all of those, so we're done. The last thing that we're going to have to do on this assignment is take a look at the powers of I. Now, we went over this earlier in my class when we did section 5.5. But when you look at the powers of I, we went through this, that I is the square root of negative 1. And that I squared, which is just going to be I times I, and if you take the square root of negative 1 times the square root of negative 1, that'd be the same as the square root of negative 1 squared, and squareds cancel square roots, and so you get negative 1. Well, I cubed is simply I squared times I. So negative 1 times I would simply be a negative I. And I to the 4th is the same as I squared times I squared, which would be negative 1 times negative 1, which we know would be 1. I to the 5th is simply I to the 4th times I. And so we get I again. And so this pattern just continually repeats. And we can make this pattern as far out as we want to go. But they're going to ask you to find things like I to the 99th power. And you don't want to make this chart out to I to the 99th. All we have to remember is we are going to divide by 4. Whatever that power is. So you can do it in your head and say, well, 4 goes into 5 once, and there's 1 left over. If the remainder is 1, it's always going to be I. Okay, so if the remainder equals 1, will always be I. 4 goes into 8 twice with 1 left over, and so the remainder is 1, and so it's I. If you divide by 4, 4 goes into 6 once, but now the remainder is 2. And so anytime the remainder is 2, it's negative 1. 4 goes into 10 twice with 2 left over, so the remainder is 2, so it's negative 1. And we can continue if the remainder is 3. Okay? 4 goes into 7 once with 3 left over. Then the answer is negative I. 4 goes into 11 twice with 3 left over, so it's negative I. And lastly then, you have the case of the remainder is 0. It goes in evenly. Anytime it goes in evenly, my answer is going to be 1. Now, for those of you that like to do it on a calculator, you're going to get decimals. And so if I divide this on my calculator, if I divide 9 by 4, I'm going to get 2.25. So anytime my decimal is 0.25, then I know that it's I. If I divide 10 by 4, I'm going to get 2.5. So if my decimal is 0.5, then I know that it's -1. If I divide 11 by 4, I get 2.75. Anytime my remainder is 0.75, or my decimal, then I know it's -I. And if I divide 12 by 4, I get 3. If I get 0.0, then it goes in evenly, and so now I know my answer is 1. So all we have to do is do this. Again, you can do it in your head. Like I know that 4 goes into 125 times, because 4 quarters is $1. So I would know that it would go in 24 times, and I would have a remainder of 3. Or if I did it in the calculator, I'd get 24.75. And so since it's 0.75, I know that it is -I. Same thing here, because my remainder is 3, I know it's -I. So you can do it whichever way works best for you. So if I take I to the 53rd, okay, let's say I don't know what that is, and I take out my calculator, and I go 53, and I divide it by 4, and that would be 13.25. And so since it's 0.25, I know that it is equal to I. And so I to the 53rd is equal to I. And so all your answers on this, when you simplify it, will either be I, -1, -I, or 1. So I just did this example for you. So you just have to make sure that you understand how to do this. So our assignment for this section is page 386, numbers 36 to 102, the multiples of 3. So make sure you start at 36 and then do 39 and then 42 and so on. Now, a way to check yourself, remember, if a number is divisible by 3, the numbers add up to a number divisible by 3. So 4 plus 2 is 6, 6 is divisible by 3, so I know I'm doing the right one. So if I get out here and I'm doing, let's say 53, well 5 plus 3 is 8, that's not divisible by 3, I've messed up somewhere, I'm not doing the right problems. So you do every third problem. Be careful to make sure you do that, just kind of every once in a while check and make sure you're doing the right one. Good luck on this assignment, and I hope this helped.